Hello everyone, I'm Terry, and in this video we're going to write out the conjugate base or the conjugate acid for these various compounds and species here. So in this first example, we want to write the conjugate base of this. Now we need to know what conjugate base means. And a base, now there's three different definitions of a base or an acid, but typically when someone just says base or acid, they mean the Bronsted-Lowry definition. And a Bronsted-Lowry base is a proton acceptor. And conjugate just means that it comes from an acid. So it's paired with something else. So it's a base that comes from another compound, and it's a base that comes from an acid. An acid that turns into a base, that acid and base, they're called conjugate pairs. Okay, so we have a proton acceptor here. So this needs to accept a proton. So if we accept, now sometimes we say just a proton, but it could be a neutron as well. But essentially it's a hydrogen without an electron. So it's H+. Well, if we gain H+ to this is called bisulfate. We now have two hydrogens, so H2. And the rest, SO4 is the same. So it's just the HSO4 that gains an H. Now, it also gains a positive charge, right? Because there's a positive charge on this hydrogen. Now, originally, it's negatively charged. It has a charge of -1. So if it has a charge of -1 and it gains a charge of +1, then the total charge is 0 or no charge. It's neutral. You can just leave it blank if you want. And this is called sulfuric acid. Okay, so we'll do the conjugate base of this one here. And again, we want to gain H+. Sometimes I do plus H+. Now, in solution, you never just see H+ by itself. If it's in water, it's always H3O+. This H+ comes from an acid, but we don't know what acid it comes from because bases always react with acid. So we just write generically H+, although just know that H+ never exists by itself. Okay, so if we gain an H, this becomes H3, C2O4. And the charge, it's negatively charged. It gains a positive charge, so it's net neutral as well. And then this one here, we gain an H+. Oh, this doesn't seem to work, does it? Ha! This is really weird. So if we gain H+, it would become NH5 2+ because it gains another positive charge. But this isn't a very good example at all because if you look at the Lewis structure to this compound, and sometimes you might see things like this on questions, 1, 2, 3, 4. So it has 5 bonds to hydrogens because there's 5 hydrogens here. 1, 2, 3, 4, 5, and it doesn't really make. Actually, we can't even make a bond here. It would have to be some kind of a salt because we just don't have enough electrons to bond with this. This would be the positively charged. Yeah, it's not going to exist actually. So this should be NH3. What it should be is NH3. That won't exist. Gain a plus H+. So then we have NH4+. So this NH4+, this is the conjugate base, technically, yeah. Okay, so we want to write the conjugate acid. So we'll go the other way, and our definition of our acid, Bronsted-Lowry definition, is a proton donor. You should get bonus points if you see things like this on your exams and quizzes. So we have, again, bisulfate here. So if it's a proton donor, then it loses H+ here. Again, it gives its H+ to a base. If it acts as an acid, it needs a base to react with. So if it loses H, that means this H is gone, so it's just SO4. And it loses a positive charge, so it becomes less positive or more negative. So if it's -1, that means it needs to be -2 or 2 minus, because it's becoming less positive. Same thing with water here. We want to lose H plus. That means we only have one H, and it's losing a positive charge. If it loses a positive charge, then it becomes more negative, so it's OH negative hydroxide here. S2 minus. Is this even possible? Right, the conjugate acid. So this means it needs to lose a proton here. Well, it doesn't have a proton to lose. Now there's the Lewis definition of an acid, which is an electron acceptor, but in this case there's no hydrogens to donate, no H plus, sorry. Therefore, it won't act as an acid, or Lewis acid, Bronsted-Lowry acid, sorry.